In this section, we're going to be looking at functions again, and their domain. So you have to recall two things here. What's a function and what is domain? So a function means for every x you have exactly one y value. And domain means the x values or the inputs. So let's just jump right into an example. That's the best way to learn some of these. So let's get after it. Example 1. Find the domain of each function. All right. So I'm gonna draw a graph for some of these, just to kind of help the two relate to each other. But on, say, the exam or quiz or anything, you're just going to be given the function, such as this. Let's say part A, f of x is equal to x plus 2. So you're going to be given that, and you're going to have to tell me what the function is. All right. So graphically, let's see what this looks like. Just going to draw a quick graph. All right. If you have x plus 2, then it is 1, 2, 1, 2, and it looks like that. See, I didn't label x and y, so it will get a little confusing. Here's x-axis, y-axis, and this is your f of x equals x plus 2. So we've already looked at how to find the domains of graphs. So now that I've just given you this, and you can relate it to a graph, you can see that the smallest x value used is negative infinity, because this keeps going and going. And the largest x value is positive infinity. So that would be our domain here. But how do you know that without looking at the graph and just looking at this? Well, there are some ways. Some of these functions, there's, I guess I'll call them little tricks. They're not tricks to figure it out. But with something like this, you just have to know it. And this comes into play of anything that's a polynomial function, which means if it's all on one line, there's no negative exponents, there's no division anywhere, then it's going to be all real numbers. And when I say all real numbers, I mean negative infinity to infinity. So what I mean by polynomial function is you could have this function, g of x, it could be 3x squared minus 7x plus 8. That's also a polynomial function. There's infinitely many of these, and they can get as big as they want. So this is also domain of all real numbers. And you can step it up a notch, and you can make these things as big and as large as you want, as long as they're all, I want to say, on one line. That you don't have a denominator with a variable in it. You don't have a square root. You don't have fractions in the exponents. H of x, you could have something like this: x to the 100 power minus 33x to the 99th power plus 17x squared minus 13. That is also a polynomial function. So this is just one of those things, it's just, and I hate saying this, it's just easier to remember. If you have a polynomial function, then it's going to be all real numbers. And a way that you can help is you'll have a calculator. So plug this in the calculator, and you'll be able to tell that it just keeps going on and on forever to negative infinity, infinity. Say, and it's the same thing for all of these here. So the domain for this one, again, is all real numbers, negative infinity to infinity. All right, so this is the easy one, and I want to get into now some that involve a little more math to figure out. So here is, I have a C, D. let's say we have b of x is equal to the square root of x plus 3. So now we're getting into square roots, and we'll get into things with we'll get into functions that have a variable in the denominator. So here, we kind of just blank. We don't know what to do here. I suggest put in your calculator, draw it, and that will be able to pretty much tell you how to get the answer. But let's see how algebraically to do it. And start by drawing a graph. It is actually an easy way for it to kind of pop out at you. All right. So 1, 2, 3. And this is what it looks like. Roughly, here's b of x. All right. So just by looking at this, you can see my smallest x value is -3, and it looks like it flattens out, but it doesn't. It just keeps going up forever. So, or over forever, and it should flatten out. I don't know what I'm saying half the time. So it keeps going forever to positive infinity. So we already know our domain just by looking at the graph. We know the domain would be -3 to infinity. I put a bracket because it's a solid dot, and I put a parenthesis always around infinity. All right, but just looking at this, and if I need to see the work done, how do I determine that how do I determine my domain is this, just based on this function? So you have to know the property about square roots. With square roots, what can you not have in the middle right here? What values can you not take the square root of? You can't take the square root of a negative number. So whatever is inside of here, this x plus 3, has to be positive, and it can be 0 also. So what you do is you take the inside of that square root, so x plus 3, and you want to make sure that that's always greater than or equal to 0. So that's what you do here. You set it greater than or equal to 0. And then you just solve it like a normal function equation. So subtract 3 from both sides. So x is greater than or equal to -3. This says the same thing that we just wrote over there. It's telling you that all the x values have to be greater than or equal to -3, which is what we wrote here, -3 to infinity. So you would get to this point, and you just say the domain then is -3 to infinity. And that's all you do. Some students do get confused by this greater than or equal, like which way you need to go. So just ask yourself, x is greater than or equal to -3. That's what I need. So if I'm going this direction, let's say we know 0 is in here. So is 0 greater than or equal to -3? Yes, it is. So then I know I'm going that direction. Try one on the other direction. Let's say -10. Is -10 greater than or equal to -3? No, it's not. So I know I need that side, and that will be the domain for this type of function. All right, let's look at part E. Let's call this M, and that's equal to x divided by x minus 2. So here we're given a fraction where there's a variable in the denominator. So this is going to be an issue for us. We need to determine what this thing's going to look like. And I'll show you how to determine it over here. But first, let's look at the graph. Here's the x-axis and the y-axis. And I actually don't have this drawn in my notes, unfortunate. Oh, I do have it drawn. All right. So it's gonna look. So this white dotted line is called an asymptote. That means it's never gonna touch that line. We're not quite there to learn what that is yet. We'll get there soon. So don't really worry about that right now. Just know that my graph is never going to touch that line. All right, and it looks like this. And there's actually one, and it's never going to touch 0 either. So it looks like that, and looks like that. So that is my m of x function. All right, it looks like two different graphs, but it's not. M of x is this and it's this. So now I need to determine the domain of this thing. And you're probably thinking it's two separate graphs, how do I do that? I'm going to show you how to write it, and it's simple. You just need to be able to recognize that you have this part of the domain, and it skips this number here, which is 2, and then it picks back up over there. So on this side, you can see if you follow your x-axis here, it keeps going and going to negative infinity. So if you just focus on this half of, so right now, it goes to negative infinity, and then it goes to, and it gets down, and it gets closer and closer to this 2, to x equals 2, but it's never going to touch it. So that's 2 with a parenthesis, because I said it's never going to touch 2. If it did touch 2, then I would be using a bracket if it was dotted. And then on this side, it keeps going up and up, but it's never going to touch 2. So that means it's a parenthesis 2, and it goes forever to infinity. All right. So we have two different domains written here, but we need to combine them into one. All right. So that's where I want to show you this, because there's a jump at 2. We don't want to include 2. So over here, how do we get this info over here? All right. So when you have a fraction like this, you need to ask yourself, what can I not have in the denominator? What would make this function invalid? Same thing with the square root a second ago. What would make the square root invalid if we had a negative number inside the square root? So we had to make that greater than or equal to 0. Here, what would make this invalid? If we had a 0 in the denominator. So we don't want the bottom to ever equal 0. So what we do is we find what that number is. We set the bottom equal to 0. And it works like this every time, as long as you have a fraction. Set the bottom equal to 0, solve for x, so plug in plus 2 on both sides. You get x is equal to 2. So what we just found, x equal 2, is what the domain is not. So notice over here, we skipped over x equals 2. That tells you here that if we plug in 2, we'll get 0 in the denominator. So 2 minus 2 would be 0. So we don't want this in the denominator, but we want everything else. That everything else we already wrote here and here. So the domain is every number except for 2. So negative infinity up to 2, and I'm not including it. And then there's going to be a little symbol I'm going to write here. I'm just going to leave a little space. And then it picks back up at 2 and goes to infinity. That little symbol here is just like a cup or a U, however you want to write it. It just means the domain is this and this. So that stands for and. So this encompasses all real numbers except for 2. All right.